Thank you. Hello, everyone. I'm Shen You. I'm a developer advocate at JVM. I primarily cover the Chinese-speaking region, and I'm passionate in open source technology. So in my spare time, I spend deeply involved the open source technology community for a decade. So it's great to be here with you all today, and I always enjoy the time in the conference. So today I will talk about how to optimize your Docker image for a Java application. The core concept is quite simple and straightforward. We will walk through a series of tactics that can help you to make your Docker image more efficiency and more considering the security issue and improve the performance. So before we dive in, we will use the typical Java application. It's a pet clinic provided by Spring Boot team. So it's a Spring Boot application, and you can compile it into an executable jar using the Gradle plugin. And we will compile the application into fake jar and copy it into our Docker image. So we will package it into a Dockerfile. So in order to build this kind of image, you need to create your Dockerfile in the root directory under your project. So if you search on the internet, you might probably get some example like this one. First, you will get your base image from Ubuntu. So then you will install the OpenJDK on top of your operating system. Then we create an app directory and make it as a working directory in your Docker container. And then we copy the fake jar from your local machine into your Docker container. And the last part, we export the 8080 port and using the Java command to start up your application. So that is simple and quite straightforward. But the question is that if you use an Ubuntu image as a base image, you can see that you use a full operating system. Also, you need to spend a lot of time to download and install all the OpenJDK stuff using on top of Ubuntu. So you can see that if you if you run the Docker file, the result image will be around 800 megabytes. So you can see that our application fed jar is around 60 megabytes, but your operating system is about 80 megabytes, and your JDK is almost 650 megabytes, which is huge. So you need to watch out the base image you use. So after you search on the internet, you might find another tutorial that teach you that you can use a Java-based image instead of the operating system one. So you can see that in this example, we switch from Ubuntu to OpenJDK. When you use the OpenJDK-based image, you can ignore and avoid the OpenJDK installation during the Dockerfile. So after you apply this approach, you can see that the JDK size reduced to 350, which is smaller. And the OpenJDK image is quite easy to understand and remember, but the problem is that based on the announcement on the Docker Hub page, the OpenJDK image has been deprecated. So not only the OpenJDK, but also happen on Java and adapt OpenJDK. So those images has been deprecated. So although you can still accessible to the OpenJDK image, but we still need to find an alternative to use as a base image. And as you know that there's plenty of OpenJDK in the market. So there's OpenJDK from Amazon, from Eclipse Tamarind project, or Oracle and IBM. So which OpenJDK should we use in our Docker image? There are several considerations when you choose the JDK, for example, the first one we need to consider is your runtime ability. As we know that different OpenJDK provide different ability. Some OpenJDK provide extra ability and fixing for your Java application. For example, we JetBrains provide JetBrains runtime, which fix a lot of issues when rendering the graphic on desktop environment. So for example, if you want to create a desktop application, maybe the JetBrains runtime is suitable for you. And the second factor we need to consider is the image size. As you can see that this is the screenshot from my Docker desktop. So I download several OpenJDK images. One is from Amazon, one is from IBM, and also from the Eclipse Xamarin and Library Card. As you can see that Amazon and IBM image is larger than others. So unless you know the reason why you need to use the image from Amazon, then you can use. But instead of that, we can use the smaller image from Library Card or Eclipse Xamarin project, so which is smaller. And the last factor you need to consider is the framework recommendation. So for example, we are working in a Spring Boot application, and the Library Card OpenJDK is officially recommended by Spring Team. So for us, we can use the Library Card provided by Perfor, which is perfect for our situation. So if you are interested in different OpenJDK and you want to know the differences and the abilities, you can read this blog post on IntelliJ IDEA, which explains the details that you need to know. After you read this article, then you can know that which JDK you should use in your project. So since we know that we can use Library Card OpenJDK to run our application, but when the Perfor provided the optimized Java image on Docker Hub, there's still a lot of variant on the Java image. So you can see that in this decision tree, they provide the library card, the runtime container JDK, or you can use the JDK or JRE with different operating system with different version. So after you walk through this decision tree, you can find the perfect one for your OpenJDK Java image. So then we know the appropriate base image from Library Card. So we can switch from OpenJDK to the Perfor Library Card OpenJRE Alpine 17 version for your base image. So the other part of the Dockerfile remain the same. We only need to switch the base image in this example. So after we apply the OpenJRE from Library Card project, you can see that the result image is around 210 megabytes. So we can know that the jar file is still remain the 60 megabytes, but the JRE part is reduced to 130 megabytes, which is smaller. So when we build the Docker image, we usually don't need to build the jar file on your local machine. We hope we can build the Java, we can build the fat jar and also the Docker image on CI server. So then we can apply a tactic using the multi-stage builds in your Dockerfile. So in the first part of your Dockerfile, we can use the OpenJDK from Library Card as a build tool. So you can run your Gradle wrapper to assemble your application into fat jar. And in stage 2, we can switch our base image using the Library Card OpenJRE and just copy the fat jar file from the previous stage and run your application using the JRE. So in this tactic, we can run all of the Dockerfile in your CI server, so don't need to relay on your local machine. So after we apply the multi-stage and also the OpenJRE from Library Hub, you can see the result image is around 210 megabytes. So we can use the show layer feature in IntelliJ IDEA. You can see that in your service tool window, you can click your Docker image and show the layers of the result image. So you can see that our flash drive is about 60 megabytes, but our JRE is about 133 megabytes in our image. So as you can see that our Spring Boot application is quite simple and small. So we actually don't use all the things in JRE. In JRE, there's debugger tool, there are main page, there are documentation, which is unnecessary for our Docker image. So we can reduce this part to make our Docker image more smaller. So the tactic we use is to create a custom runtime using the JLink tool, which is provided in JDK. So in this example, we separate our Dockerfile into 3 parts. The first part, we use the OpenJDK from Library Hub as a build tool to build our flash job. In the second stage, in this example, we use the JLink provided inside the JDK. In the command, you can see that we strip the debugger tool and we remove the main page and some header file as the documentation, so we can create a custom Java runtime for our application. And in the third part of Dockerfile, we can use a very small Linux distribution Alpine as a base image. Then we can set up the Java environment and also your environment variable inside your Docker image. Then we can copy the fetch jar from our first stage and copy the custom Java runtime from the second stage. So basically, you can create from scratch using Alpine, but but using your custom Java runtime. So after we apply this approach, you can see that our JRE reduced from 133 megabytes to 90 megabytes, so which is smaller. So the result image is around 160 megabytes. But as you can see that our application is quite small, but there are a lot of different modules in your JRE. But we don't use all of the modules from our JRE. So is there any way that we can remove the unnecessary modules from our JRE? So actually, there's another tool called JDEX, which can analyze your jar file to know which modules that you use in your Java runtime. So we can do a little modification in our stage 2. On stage 2, we can copy the jar file from your previous stage, and then we can use the jar command to filter out your jar file, and then we can use JDEX to analyze your jar file, and then we can know which modules you use and export it as a text file. So you can see that we can export it as a modules.txt file. So when we build the custom Java runtime using JLink, you can import your module text file into JLink. So the JLink knows which modules you use for your application, which can squeeze a little bit for your JRE. So after we apply this tactic by combination of the JDEX and JLink, you can see that the result JRE is around 60 megabytes, and the total image size is around 125 megabytes, which is the smallest one. So when we working on a Docker image, we are not only consider the image size, but also we need to think about the security risk. So for example, in the left-hand side, you can see that it's a regular Alpine Linux, and we can use the Docker desktop. The dashboard provides information about the security risk. And as you can see that the Alpine Linux has some vulnerability about the OpenSSL. So when the Eclipse Tamarind project used Alpine Linux as a base image to build the OpenJRE or JDK, so the security risk kind of like inherit from the base image. So the Tamarind image also have the same security risk in the OpenJRE and OpenJDK. So to avoid this security risk, there is a concept called destroy-less image. So what is destroy-less image? Basically, the image removes the unnecessary packaging from your operating system. So they use fewer packages in your operating system, and they also remove the permission from root. And also, you cannot create directory in operating system, and you also remove the shell command. So actually, the only thing you can do is to use this image to run your application. So after you apply the destroy-less image, it only contains your application and your runtime dependencies, which can avoid all the security risks. So let me give you an example. The left-hand side is the regular Debian Linux image. So you can see that there's a different security risk listed in the vulnerabilities tab. And also, it installed 125 packages in the Debian Linux system. And the right-hand side is the distro-less Debian provided by Google. And you can see that it only installed 42 packages in Debian Linux system. And there's zero vulnerability in this image, so which is safer to use. So when we apply this kind of distro-less image approach to your Dockerfile, we can separate our Dockerfile into two parts. The first part, we can use the distro-less image to build your application. In this example, I use another vendor called ChainGuard, which is focusing providing the distro-less image in the market. So in the first step, we use the ChainGuard JDK to build our job file. And the second part, we use the ChainGuard JRE to run your application. So you can see that the Dockerfile is quite simple. And we just need to switch from JDK to JRE and using a distro-less image. And if you really want to apply the approach that we previously used to squeeze your JRE runtime, then you need to use another tool provided from ChainGuard, which is called AppCode. So using AppCode, you can build your own custom distro image using AppCode, so you can squeeze your JRE a little bit. But it will take another extra effort to do that. So if you want to save your time, you can just use the JRE that provided by ChainGuard, so you can save your time. But it will increase a little bit of your image size. Okay, so after we consider the security risk, then we need to consider the performance. As you know that as a Java application, the startup time is a little longer than native binary. So if you want to boost your performance, there's a way that we can compile our fake jar using Gradle VM. So Gradle VM is a new VM provided by Oracle, which can help you to compile the fake jar into a native binary. So let's apply this native build tool into our Dockerfile. And if you are using Spring Boot framework, you are lucky because the Spring team officially support the native image. So when you create your new project or you're in your existing project, you can add a dependency called JVM native support. So after you apply this dependency, you can get a series of Gradle tasks prefixed by native. So in our example, we can use native compile task that can help you to build your Spring Boot application into a native binary. So in our Dockerfile, we need to switch our build tool from the OpenJDK to native image kit container, which is also provided by the library card project. So the library card project, in this container, they provide the OpenJDK 17 and with the JVM 22 as your build tool. So in this build tool, we can use the native compile test, Gradle task to compile your fat jar into a native binary. And in the set 2, we can also use another smaller Linux distribution and just run your native binary. So you just copy the binary from your previous page and then just run it. So you don't need to use a JRE runtime. This is just a simple comparison of the startup time using my local machine. So if you if you run an executable jar in my local machine, it takes about 7 seconds to start up your application. But if you compile your fake jar into a native image, it only takes about 1 second to start up your application. So which is huge improvement for your performance. So it's kind of magic to improve your performance, but it also brings some downsides. So for example, if you use this kind of native image tool to build your application, it highly relies on your build environment. So sometimes the tool improves, and sometimes you need to upgrade your image, and also you need to upgrade your build tool, and it takes a lot of different effort. And sometimes you will face some failure when you build your application. So for me, sometimes we also need to build from scratch to build the whole native build tool for your application. So it's kind of really hard. Also, when you build this kind of native image, the build time is longer than usual. So for example, when I test the native image, it cost me about 15 minutes to 20 minutes to build the image. So it's much longer than the usual. So if you want to go this approach, the build time really matters. Also, it won't decrease your image size. Instead, it will increase your image size. For example, in the previous step, if you use the squeeze JRE, then we only have 122 megabytes for your Docker image. But after you apply the native image, the image size is around 200 megabytes. So it will increase. So that's the downside when you're using this approach. So the last tactic we want to talk about is you can utilize the Gradle plugins. So I will say that the Docker ecosystem is quite mature right now. So for example, in the Spring Boot framework, it provides a Gradle plugin that can help you to build your fake jar and also build the image for you just by one simple click. So you can use the IntelliJ IDEA Gradle tool window, and you can click the build image command that can help you to build the fake jar. Also, they can use the build pack to help you to detect if your local machine can build the native image. They can also help you to build the native image and package it into a Docker image. But if you want to go this approach, your CI server need to install the Docker in Docker approach, so which will take another effort. So you need to consider about that. And if you are not working in a Spring Boot application, you just using you can use the Gradle plugin provided by Google Cloud. So JIT plugin can detect your application type and help you to build the Java application into FedJar and packaging it into a Docker image without the Dockerfile. So if you want to improve your developer experience, you can use this kind of Gradle plugin to help you to boost your productivity. So let's go a quick recap for today's talk. So first, we want to remind you that you need to avoid building image from scratch because you can use some preview Java image as a base image. But when you choose the Java-based image, you need to consider and use an appropriate base image. For example, you can use the library Java image or use the Eclipse Tamarind project, the base image from that. Then we can apply the multi-stage build using the Dockerfile. So you can split into several stages. The first stage you can compile your application into FedJar, and the later stage you can package it into a Docker image. And when you compile your Dockerfile, you can consider to reduce the size of JRE by a combination of the JDEP and JLink. So the JDEP can analyze your the jar file to know which module that you use, and the JLink can filter out the unnecessary part of the JRE and only contain the module and the tool that you need to run in your Java application. And we also need to consider the security risk. So in our tactic, we need to use a distroless image approach, which removes the shell environment in your operating system. So only thing you can do is to use distroless image to run your application and avoid the security risk. And if you want to boost your performance, you can try JVM to compile your FedJar into a native image and then package it into a very small Linux distribution. And the last part, if you consider to improve your developer experience, you can utilize the Gradle plugin provided by JIT or the Spring Boot framework. So then you can forget how to write the Docker file and just double click the Gradle task and then build the Docker image. So that's all for today, but for me, I will say that there is no silver bullet for your project. So when you're working in a Java application, you need to consider different factors in your development. For example, you need to consider the image size, the build time, and the security and performance, and also the developer experience. So you need to find a balance in your project, and you can only apply the important factor for your project. So for example, if the build time is really matter, then you can you can try to reduce the build time that we use for the tactic. So that's all for today, and if you are interested in open source technology, we have a conference called HKOSCon in Taiwan, and this year we hosted in August 3rd and 4th. It will be a 2 days conference in Taipei. So if you are interested in that, welcome to Taiwan, and we have different topics in the conference. Okay, thank you all for today, and hope the tactic is really beneficial for you. Thank you.
Professor, Mr. Fan, so I think we don't have much time for the Q&A. I think we can have a quick one question if you have any. Anyone have a question? Want to ask? Yes.
Can you recommend a JRE image for building Android application?
So sorry again?
JDK image for building Android apps.
Oh, you mean if you want to compile your Java application for Android application?
Yeah.
Then you will need to use the Gradle image that can help you to build the Android application. Because in my in my example, we just build a web application. But if you want to build a Android application, you need to switch your best image to Gradle. Then it will help you to build the Android application. Yes. And I think there's not much way to reduce the JRE part. Yeah, because it's an Android application.
So I think we kind of, so if you have any further questions, feel free to reach out to Shin Yao, maybe outside the room, and he will be happy to make those with you and with any architect. So for our next session, we start in 11:45 and with the topic of moving from the PMPC to public money, public transparent digital service. What went wrong and what was we improving? So it will be